A body of mass 0.5 kilogram travels in a straight line with velocity v equals to ax power 3 by 2, where a equals to 5 meter power minus 1 by 2 second inverse. What is the work done by the net force during its displacement from x equals to 0 to x equals to 2 meter? So there is a body of mass 0.5 kilogram and it is traveling in a straight line. So it has some velocity v that is equals to ax power 3 by 2. Here they have given the value of a. So a equals to 5 meter power minus 1 by 2 second power minus 1. So please see, a is not acceleration here. So a has some value with some units. Okay, it is already given in the question. Please see that. What is the work done by the net force during its displacement from x equals to 0 to 2 meter? Okay, now we have written v equals to ax power 3 by 2. So initially we have to substitute x equals to 0. So v equals to 5 into, so this 5 into 0 power 3 by 2. So what is the answer? It is 0. What about the final velocity? v2 equals to 2 meters. So 5 into, instead of x you have to substitute 2 power 3 by 2. So what is that? 5. So 5 will be there. It is 2 cube. It is the square root of 2 cube. So square root 2 cube. So what is the answer? So you have to take, you can take 1 2 for these two twos outside. Then it will be 10 root 2. Okay. Now what is the question? What is the work done by the net force? So work done by the net force is nothing but change in kinetic energy here. So it is half m v2 square minus half m v1 square. So it is half, what is the value of mass? It is 0.5 kilogram, v2 square minus v1 square, that is 10 root 2 whole square minus 0 square. So it is 200 minus 0, so the answer is 50. So this is the answer. The relation between displacement x and time t of a particle moving under constant force is t equals to under root x plus 3, where x is in meter and t in seconds. Determine the displacement of the particle at instant when its velocity is 0. Work done by the force in the first 6 seconds. Okay. So here there is a relation between displacement and time, that is t equals to root x plus 3, and it is under constant force. That means it is under constant acceleration. Okay, it is constant force. It means constant acceleration. And first question is displacement of particle at the instant when velocity is 0. So we have to rearrange this equation. It is so simple. So t equals to root over x plus 3. So from that I can write root over x equals to t minus 3. So from that I am squaring the equation. So it's like root x is equals to t minus 3. So on squaring it will be x is equals to t minus 3 whole square. So what is the value of velocity? Velocity is nothing but change in displacement by time. So it is dx by dt. So the answer is 2 into t minus 3. So this is the velocity. So we have to find the displacement of particle when velocity is 0. So now we got the value of velocity, that is 2 into t minus 3, and this should be 0. And when it was 0, what is the displacement? So that is the question. So it is like 2t minus 6 equals to 0, and that is 2t equals to 6, so t equals to 3. So at third second, that is when t equals to 3 seconds, the the velocity was 0. So we have found the time. Now we have to substitute this t equals to 3 in the displacement equation, so that we are going to get the displacement. Okay, because the question is displacement. What is the value of displacement? We have to find that. Okay, so we have used the condition velocity equals to 0. We have used it and we have got a time, that the time was equals to 3 seconds. So we are substituting this t equals to 3 in the displacement equation. So it is 3 minus 3 whole square, it is 0. So what is the answer? Displacement was 0. Next, what is the work done by the force in 6 seconds? So what is the value of work done? Work done is equals to force into displacement. So this is delta x. So now for 0 to 6 seconds, now you have to take x is equals to t minus 3 whole square. Now substitute t equals to 0. Now what is the value of x? X is equals to 0 minus 3 whole square, that is 3 square. What is that? It is 9 only. So now you take t value as 6. So it is 6 minus 3 whole square, that is also 3 square, that is 9. So initially it was at displacement, it was at 9 meters. So finally also it was at 9 meter only. So what is the delta x? It is 0 because 9 minus 9 is 0. So if delta x is 0, then the work done is 0. A chain is placed on a frictionless table such that its 1 by 5 part of it is hanging down over the edge of the table. If the length of the chain be L and the mass be M, then how much work will be done in pulling up the hanging part of the chain back on the table? Okay, so there is a long chain which is of length L. Okay, and it's 1 by 5, that is 1 by 5th part is hanging down. So that means, so here there is L by 5. That means, so remaining 4L by 5 of the part is here. So L by 5 of the part is hanging down like this. And what is the work done in pulling up this hanging part to the chain, hanging point of part of the chain back on the table? So that is what is asked in the question. Now, so please listen to this carefully. So the total length of the chain is L. So, and the mass of the total chain, so total length of L of the chain is M. Okay. Then what is the mass of L by 5? L by 5th part of the chain, it is, so for L it is M. Okay. For length L, the mass was M. So what will be the mass of the length L by 5? It is into L by 5. So the answer is M by 5. This is the mass of the chain which is hanging. Now we got this one. We know what is the work done. It is mg into h. So we got the value of m. It is m by 5 and the value of g is known. Now what is the height we have to take? So please see, for this total mass L by 5. So if suppose this is this L by 5th part which is hanging, the center of gravity for this center of mass will be at the center point. Okay, so the height which we have to consider is only this much. Okay, that is half of L by 5 is what we have to consider. So it is L by 5 into 1 by 2, so it is L by 10. So that is the reason we have taken, instead of height it is L by 10. So the answer is mgl by 50. Okay, please note this. We may use this in. A man pulls a box on a horizontal floor through a distance of 20 meters with a force of 30 Newton applied along a rope tied to a box and making an angle 60 degree with the horizontal. Calculate the work done. So here there is a box and this is moved 20 meters horizontally with a force of 30 Newton, and that force is making an angle 60 degree with the horizontal. Now what is the work done? So it is simple, it is F dot S. So it is F is cos theta. So please remember one more thing. So here it is not just S cos theta, it is like the it is like force in the direction of displacement or displacement in the direction of force. So that is what is the main thing which we have to remember. So this is the direction of displacement, it is like this, but the force is like this. So what is the direction of force which we have to, which component of force we have to take, which component of force is useful in moving the box horizontally? That is the horizontal component. Okay, so what is that force? So if this is 60 degree and this is F, then this is F into cos 60. So that is how we have to write. Okay, so please don't blindly think it is F as cos theta. So you have to remember the reason why it is. So you have to take the force, component of force in the direction of displacement. So here that's why we are taking, so F cos 60. So it is value of F is what is the value of F? 30, S is 20 and cos 60 is 1 by 2. So 300 joule. This is the answer.